boosters in the center core to balance aerodynamic and structural loads on the vehicle. About 70% through the first stage's burn, the two side boosters will separate and come back to Earth for simultaneous landings at Cape Canaveral Air Force Station on Landing Zone 1 and Landing Zone 2. At this point, the mission will proceed just like a standard Falcon 9 flight. The center core will keep firing for another minute, then will perform a standard stage separation from the second stage. We will attempt to land the center core on our drone ship, Of Course I Still Love You, which is currently stationed about 650 nautical miles off the coast of Florida in the Atlantic Ocean. It's worth mentioning that for this mission, bringing back the center core will be more challenging than usual, as our booster will be coming in extra hot and our drone ship is positioned almost double the normal distance from land. Given this distance, we may not receive any video of landing. Now, if we are able to land all three cores tonight, it will be a particularly exciting achievement. The second stage is exactly the same as any other Falcon 9 flight. Tonight, the second stage will move through 4 different orbits in order to deliver the payloads on this mission. The first and second are low Earth orbit, or LEO. The third is a transfer orbit, and the final is medium Earth orbit, or MEO.
Speaking of those satellites, all 24 of them are safely enclosed inside of the 17-foot diameter payload fairing, which is the pointed structure on the very top of the rocket. This protects the payload from aerothermal loads, heating, and contamination during ascent. Once we reach the vacuum of space, we no longer need them, so we will jettison the fairing as the second stage continues on its journey to orbit. We will be attempting to recover the fairing pieces tonight with our recovery vessel, Miss Tree, formerly known as Mr. Steven. Our hope is to catch one of the fairing pieces in the ship's nets and recover the other piece from the water. If we are not successful with our catch attempt, Miss Tree will recover both pieces from the water. Let's check in on how the countdown is going.
It's T-minus 14 minutes, 10 seconds and counting down. Good evening. I'm John Isberger, the Falcon Principal Integration Engineer at SpaceX. Now we are at T-minus 14 minutes from the launch of the Falcon Heavy, and all systems are go for launch on the half hour. Falcon Heavy rolled out to the pad with the payload 27 hours ago and went vertical about 7 hours later. Now we did have a ground hydraulic issue early in the count, but it was fixed, and currently everything is go. We cleared the pad deck at T-minus 9 hours to begin hazardous operations. And just before we began the webcast, the SpaceX launch director pulled the 9 members of the launch team. You can see the firing room at Kennedy Space Center. We pulled the team, got to go for propellant loading and launch. Now we're currently loading propellant on all 3 first stage boosters and the second stage. Now we load 2 propellants on the Falcon Heavy. One is liquid oxygen called LOX. No oxygen is in space to support combustion, so we have to bring our own. We chill it to get it as dense as we can in order to maximize how much we load. The second propellant is our fuel, RP1. That's essentially a purified kerosene. Now these 2 propellants have a long history of usage. The Saturn V first stage, flown from this very pad on the moon missions 50 years ago, used LOX and kerosene. Now for the satellites on tonight's flight, everything is go. The last transfer to internal power is coming up in just half a minute. Other than that, the spacecraft teams here at the Cape are monitoring data as we proceed to T0. And I expect a lot of satellite builders and operators are anticipating getting data from space with a lot of enthusiasm. Now we're launching out of the Eastern Range, supported by Cape Canaveral Air Force Station. The range is currently go. They're prepared to support today's mission. They're making sure that the sea space, the airspace is cleared. No one's nearby to get in the way of tonight's launch. They're also releasing balloons, which brings up the question of how's the weather? The good news is the weather is looking very good. Ground level winds are acceptable. Upper altitude winds are also acceptable. Now, as Alex mentioned, we started the day with a 4-hour window. However, now that we are into LOX loading, we don't have the ability to hold the countdown. Falcon Heavy is 3 rockets counting down at the same time. We need so much liquid oxygen that we would have to scrub tonight in order to use the backup date tomorrow at the same opening of the window time, 11:30 p.m. Eastern. Now, if you followed the SpaceX webcast in the past, you've probably heard me remind everyone that launch is hard. Well, that goes double tonight. as we're going to fly the most demanding mission profile for a Falcon rocket ever. So the SpaceX team has their conservative dial set at 11 and stands ready to take time to look into anything out of the norm. Now, as the energy from the team gathering below me outside of the control center is growing, we are go at T-minus 10 minutes and 51 seconds.
As we mentioned earlier, tonight's launch is for the U.S. Air Force and is a rideshare mission with 24 satellites. The mission involves the largest number of government agencies we've had as mission partners, including the Air Force, the Naval Academy, NASA, NOAA, and the Taiwan Space Agency. The specific agency inside the Air Force responsible for overseeing tonight's mission is the Space and Missile Systems Center, or SMC. Let's get some more details about what the agency does and is responsible for.
What is SMC? SMC stands for Space and Missile Systems Center, but that's just a name. Who we are, what we do, it's much more than just a name. We're the dedicated men and women who develop, acquire, field, and sustain cutting-edge space experiments and operational satellites. Our mission, deliver resilient and affordable space capabilities. What does that mean? It means we enhance military communication systems, acquire next-generation GPS satellites, develop advanced remote sensing and service capabilities, field cutting-edge rocket systems, modernize the United States satellite control structure, create never-before-seen technology, and deliver sustained, unrivaled space superiority for our nation. Let's face it, the world's changing. Along with it, SMC is changing to ensure the United States remains the vanguard of space capability and scientific understanding. We dubbed our aggressive and innovative new approach to the way we work SMC 2.0. That means speed, to quickly implement the best solutions to new problems. Partnerships, to forge the relationships necessary for the mutual benefit of the U.S. and our international allies. Innovation, to capitalize on the most advanced cutting-edge technology in the world. Culture, to inspire the necessary risk-taking that will propel us into the future. And enterprise, to share our vision of accelerated and affordable space systems for the Department of Defense. Initially founded in 1954 to develop the first intercontinental ballistic missile, SMC has produced unprecedented and unparalleled national defense space technology for over 60 years. During this time, we've been called upon to support manned space, anti-satellite, and missile defense programs while continuously increasing our space capability. That's where we came from. But a more important question is, where are we going? Humans have always been explorers. We venture to discover that which is unknown. At SMC, we push the boundaries of the known and fight every single day to enhance our technological capabilities, launching past the limits of the sky. We are the pathfinders to the high frontier, and we are building the future of space.
The SpaceX team continues to count down for launch for the nighttime launch of Falcon Heavy. I remember watching the night launch of Saturn V on the Apollo 17 mission in December 1972, and it turned night into day. We're expecting the same tonight from 27 Merlin engines. We're currently at T-minus 7 minutes 28 seconds and counting. Fuel loading is continuing. We're about to wrap up fuel loading on the 3 first stage boosters over the next minute. Liquid oxygen loading is continuing. That'll wrap up between 3 and 2 minutes before liftoff on all the stages. We've had the report the last satellite has gone on internal power just a moment ago. Everything's looking good on the satellites. Now a major activity coming up here in another 2.5 minutes is retract of the strongback. We'll see the clamps open up around the second stage. The strongback will recline about 2 degrees in preparation for launch. We're also just inside T-minus 7 minutes. We've begun chilling in the 27 Merlin 1D engines. Now a lot's going to happen in the first 4 minutes of flight of the Falcon Heavy. We'll first light the 2 side boosters and then the center core. The flight computer on Falcon Heavy will check the power on all the engines, then command release from the ground hold downs at T0, so we lift off at T-minus 0. Right after we lift off, we're at full power of over 5.1 million pounds of thrust. 40 seconds into flight, we decrease power on the two side boosters in preparation for maximum aerodynamic loads on the vehicle. Once we get through this period, Falcon Heavy will throttle back up to power on the two side boosters. We now are 2 minutes into flight and we're again reducing thrust on the two side boosters. This time it's to decrease forces on the rocket structure, especially that structure that holds the side boosters to the center core. The acceleration is building every second as we burn propellant and we're lightening the rocket. So we need to throttle down the side boosters by physically turning off engines to keep the loads below the maximum allowable. 2.5 minutes into flight, we fully turn off the side boosters, called BECO, Booster Engine Cutoff. Then we'll use high pressure gas separation system that's mounted on the top and bottom of the center core. That'll unlock the two side boosters and push them away. Now once we're clear of the side boosters, the center core will throttle up to full power and burn another minute. Finally, at just past 3.5 minutes after liftoff, the center core shuts down, main engine cutoff, and the second stage separates. Now from this point on, it's like a Falcon 9 mission, other than we do happen to have 3 first stage rockets returning to Earth at both Cape Canaveral and the drone ship. Meanwhile, on the way into orbit, the fairing will separate, the second stage engine will undergo a series of 4 burns, eventually delivering all 24 satellites to their intended orbits. Now it's a demanding sequence of events for the Falcon Heavy tonight. But from this point on, everything is looking good. We're at 4.5 minutes, we're getting ready to recline the strongback, so let's watch and listen to the final countdown.
Back starting to retract. And negative Y LOX load is closed out. And positive Y LOX load is closed out. Strong back lower is closed out. And stage 1 LOX load is closed out. Vehicles on internal power. And stage 2 LOX load is closed out.
Ground gas close, that's complete.
And the vehicle is in startup.
This is the mission director. Go for launch.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
Vehicle's pitching downrange.
T-plus 25 seconds into flight under the thrust of over 5 million pounds. Falcon Heavy is headed to space. We're getting ready to throttle down for passing through the period of maximum dynamic pressure. We've heard call out of throttle bucket for side core. We're through max Q.
Vehicle is supersonic.
Everything continuing to look good on the Merlin 1D engines. We're throttling back up on the side boosters to full power. A minute 15 seconds into flight. Performance looks nominal. Currently, the next event coming up in about 2 minutes, we'll hear call out of chill-in of the MVAC-D engine. That allows liquid oxygen to the top of the turbo pump to get the second stage engine ready to chill for ignition in just a couple of minutes. We're 2 minutes into flight. We've begun to decrease thrust on the side boosters to minimize acceleration and loads on the Falcon Heavy structure. We've turned off one engine on each of the side boosters to decrease that load. Now our next major event coming up here in about 10 seconds, shutdown and separation of the side boosters. The view should be the side booster cameras on two sides and the center core in the middle.
Booster shutdown.
Booster separation confirmed.
Over the cheering in the background, it's going on midnight, but a lot of people here at SpaceX, side boosters have separated. They're getting ready for their burn back to Cape Canaveral. You can see on the left and right views, the side boosters have ignited. The center core continues under full power. Everything looking good on the Falcon Heavy. Next event coming up in about 15 seconds will be shutdown of the center core, followed by stage separation and ignition of the second stage engine. Good views of the two side boosters under the thrust of 3 engines each, slowing down their velocity and coming back towards Cape Canaveral. We have shutdown on the center core.
Go. Stage separation confirmed.
We have successful separation and ignition. We're coming up on shutdown of the two side boosters.
Side booster shutdown.
And we've heard the call out side booster boost back shutdown. The center core, you can see, is not doing a boost back. It's headed downrange to the drone ship. Here comes fairing separation.
Cross-ranger nominal. Fairing separation confirmed.
We have confirmation of the payload fairing separation. So far, 4 minutes, 17 seconds into flight. Second stage looking good, headed to low Earth orbit, carrying the 24 satellites. The side boosters have done their first boon, coming back to Cape Canaveral. The center core has separated and is beginning its long coast downrange to the drone ship in the Atlantic Ocean. So at 4 minutes, 35 seconds and counting, everything looking good on Falcon Heavy.
Now those side boosters are making their way back. Their grid fins on all 3 boosters should be deployed, and those are help guiding them to their landing zones. As a reminder, today we will be attempting to recover all 3 of these first stages, and all 3 boosters are currently making their way home. In just a few minutes, the side boosters will execute an entry burn followed by a landing burn, and the center core will complete the same burns just a few minutes later. Both burns are used to slow the stage's speed down rapidly before landing.
At the time of separation, the side boosters were traveling slow enough to turn around and make their way back to land at our side-by-side landing pads. The center core is going too fast to efficiently return to the Cape, so we're using our autonomous drone ship, Of Course I Still Love You, as we mentioned earlier. As a reminder, our drone ship is positioned twice as far offshore than normal, so we may not get visuals of landing tonight. Also coming up in a few minutes will be the call out for second engine cutoff. So coming up in about a minute here, we're going to look for that side booster reentry burn to begin. Shortly after that, that should end about 20 seconds later. You can see both of those boosters on the infrared camera on the left side of your screen. Again, about 30 seconds until we expect those side boosters entry burn to begin. So keep an eye on the left side of your screen. In about 10 seconds, we should see those side boosters reignite for their entry burn.
Side booster entry burn startup.
And we have confirmation that the entry burn has begun. And in about 15 seconds from now, we expect that to end. Oh, wow. Hear the crowd cheer behind me. And that entry burn has completed. Note that second engine cutoff and the center core will be landing almost at the same time. So we're going to have a few events in succession at about T plus 8 minutes and 21 seconds.
Both side booster FTS is safed. Stage 2 FTS is safe.
In terminal guidance.
In about 20 seconds, we're going to look for that side booster landing burn to begin on both boosters.
Side boosters transonic.
About 10 seconds away.
Side booster landing burn startup.
We've heard the call out for side booster landing burn startup, and there you see it on your screen. See it coming towards our 2 landing pads. See those landing legs deploy. Confirmed side booster landing. What an iconic view. We've also, at the same time, I believe we've had second engine cutoff at the same time. As we mentioned earlier, the center core entry and landing is going to be risky. During entry, it'll face more heating and dynamic pressure than we've ever experienced on Falcon 9 or Heavy flight before. Why, you ask? Because we have to lift the second stage higher and faster than other Falcon Heavy flights in order to have enough performance in it to execute 4 burns into all the different orbits. So coming up at T plus 9 minutes and 39 seconds, we should see the center core entry burn ending.
Center core entry burn.
Oh, we have the confirmation. Looks like that was the confirmation for it to begin. So we're a little bit off the timeline.
Center core entry burn shut down.
And we had just heard the confirmation that center core entry burn has shut down. And now that the entry burn is complete, the center core is moving back about 20% faster than it was at the end of the Falcon Heavy 2 arabsat entry burn.
First stage KPL as expected.
Now we're coming up, we're just about a minute away from that center core landing burn beginning, and as we've been mentioning, this will be the most difficult landing that we've had to date. This will be a 3-engine burn. That center engine will start up first, and then 2 outer engines will start up as well for that landing burn. Now we're just 30 seconds away from that center core landing. And it's no surprise that we do not have a live view of that center core as it's coming down, but it looks like we got a live view of the drone ship there. Of course, I Still Love You. If you're just now tuning in, we're just about 10 seconds away from that center core landing burn beginning.
Stage 1 landing burn has started.
And we have confirmation that the center core landing burn has begun. Could see that coming down on Of Course I Still Love You. Got a pretty good view. And as you can see on our screen, it looks like our center core did not make it on our drone ship Of Course I Still Love You tonight. Again, as we've been mentioning, this was the most challenging landing that we've had to date, and this is our secondary mission. So our primary mission, we just heard the call out for a good orbit of our second stage. So we are actually just moments away from our first deployment of the evening for Oculus ASR, which was developed by students at Michigan Technological University. We will be passing beyond the Bermuda ground station, so there is a chance that telemetry may cut out a few seconds before deployment, in which case we won't be able to see the satellite actually deploy on camera or get confirmation of a successful deployment until telemetry is restored. Now we're just about 30 seconds away from that deployment, so we'll listen into the nets for that confirmation. Looks like we still have that live view. Might have a chance to see this deployment live on camera. Again, we are waiting for the Oculus satellite deployment. And as we expected, looks like we lost that live view. So we will wait to get some confirmation of that deployment, and we will update you guys in a few minutes later on. We're going to take a quick break. We will be leaving ground stations for the next few minutes where we are nothing to see. So we are going to take a quick break. We will be back around. We will be leaving you with 20 minutes for our next set of deployments. Where we are throughout the and it's worth noting that since we won't require ground station coverage again until T plus 21 minutes, we are going to miss that first P-Pod 1 CubeSat deployment. See you back here in about 6 minutes.
welcome back to the webcast for the STP-2 Falcon Heavy mission. We're T plus 20 minutes and 7 seconds and counting. Right now, as we left the webcast, we were waiting to see the Oculus satellite deploy. We didn't have confirmation when we lost signal over Bermuda. That was normal, losing signal. You do it when you pass beyond line of sight. We also should have had a minute and a half or so ago the first P-Pod #1 open up and deploy 2 CubeSats for the Naval Research Laboratory. But we're waiting until we reacquire signal over the Ascension Island tracking station around the equator in the middle of the Atlantic so that we can understand whether or not the Oculus satellite deployed and how P-Pod 1 deployed also. While we're waiting for acquisition of signal from Ascension, just to recap, we had a great launch of Falcon Heavy. The 2 side boosters did their choreographed landing at landing zones 1 and 2. The center core, as you heard from the people and may have seen a shot on the screen, missed the drone ship. We knew this was going to be the toughest reentry. We are getting data back, so the team will understand over the next hours and days how things have gone. It looks like now we're beginning to reacquire signal over Ascension Island. We're waiting to hear a call out how the first 2 satellite deploys have gone. It appears we have confirmation that the Oculus satellite was separated and P-Pod #1 opened up, deploying the Naval Research Laboratory satellites. There's a view from space, and if you remember the view just before we left, on the bottom left was the Oculus satellite, had a white coloring to it, and it's no longer there. Now we're going to cover the last of the 8 P-Pod satellites that are coming up for deployment, and that's going to take about 30 minutes to get through this sequence. The next deployment comes up just before T plus 25 minutes. Now these 8 deployers will open, and they'll release 11 satellites. Now, if you've watched our coverage from other launches like Iridium, you know that the 1 camera we have on top of the payload attach fitting cannot see all sides of the dispenser holding the satellites. Because of the positioning right there, as you see on your screen, of the 1 camera, we won't be able to see all of the CubeSat deployments today. In particular, the next 3 P-Pods, 2, 3, and 4 on the back side, we won't be able to pick those up. However, as the second stage does maneuver in orbit in the sunlight, we might be able to pick up a glint of the sun off of the CubeSats as they move away from the second stage. Now the next deployment coming up just before 25 minutes is known as Falcon Sat 7. This is an optical telescope for the United States Air Force Academy. The CubeSat, when it is ejected, will eventually deploy a rigid boom that holds a membrane that acts like a lens in a telescope. And once that membrane is rigid, it will allow imaging of the sun. So this is a deployable optical telescope for the Air Force Academy. However, as I said, we won't be able to see it. We'll have to wait for call out to confirm the separation.
Gabon acquisition of signal.
We've heard a call out. Gabon has acquisition of signal. As we are approaching the African coastline, the next ground station beyond Ascension Island is picking up the signal from Falcon Heavy second stage. Coming up on deployment in about 5 seconds.
P-Pod 2 deploy confirmed.
And there's the call out from the avionics engineer. Always a little bit tense as you're waiting for them to confirm that the signal indicates that the door is open. Inside of each of the deployers is a spring that pushes out the CubeSats. And what we have is confirmation that the Air Force Academy deployable optical telescope should be in orbit on its own now. Now we've got about 235 seconds until we get to the next deployment. Coming up just about a minute away from the third P-Pod opening. Inside this deployer is a single CubeSat. It's known as Armadillo from the University of Texas. Now, Armadillo is an acronym, and bear with me. It stands for Atmospheric Related Measurements and Detection of Sub-Millimeter Objects. Quite a mouthful. Primary goal is to use a dust detector to characterize the space debris environment, focusing on sub-millimeter debris that can't be seen by Earth-based telescopes. Now, this satellite deployer is mounted on the opposite side of the dispenser, so again, we'll only have verbal call out when it separates.
P-Pod 3 deploy confirmed.
And confirmation, P-Pod number 3 has opened. Armadillo should be on its way into orbit in the vacuum of space. Next up will be a quick turnaround, only about 145 seconds until we get to the next deployment. Okay, we're just over 50 seconds away from the deployment of P-Pod 4. This time we're going to have 2 CubeSats coming out of the deployer. Again, it's on the backside of the dispenser. This is the last one on the backside of the P-Pods. Satellites are called PSAT and BRICSAT. PSAT's an amateur communication satellite, and BRICSAT is a small satellite that has a micro-propulsion system to perform experiments with attitude control. Satellites are out of the United States Naval Academy.
P-Pod 4 deploy confirmed.
And we have confirmation over the net from
Acquisition
avionics.
HPK.
P-Pod number 4 has deployed. At the same time, we now have acquisition of signal over Hartebeestok, known as HBK, in Africa. And we've got about 165 seconds until P-Pod 5 opens up. All right, P-Pod 5 is going to be opening up here in just about 50 seconds. This P-Pod is holding a CubeSat called Prometheus for Special Ops Command. Now hopefully we might be able to get to see some of these now that they're deploying from the dispenser on the side of the camera. Currently on the map you can see we're passing over Africa in contact with the Hartebeestok ground station. We'll be losing signal here shortly from Gabon in West Africa. Now in this view, the P-Pod dispenser is located probably at about the 2 o'clock position around the dispenser, the very top. So you've got to look up there and we might see something going by. However, we're also starting to get a sun flare off of the camera.
P-Pod 5 deploy confirmed.
We've heard the confirmation. P-Pod 5 is deployed. So we're through 5. We've got 3 more P-Pods to go. The last one will be deploying at T plus 50 minutes. So we've got another 16 minutes to get through this sequence. So the next one coming up should be deploying in about 285 seconds, a little more than 4.5 minutes almost.
Unknown loss of signal expected. Mauritius acquisition of signal.
We're a little more than a minute away from the next deployment over Africa. In fact, the next two P-pods that will open and deploy satellites are in support of the NASA Enhanced Tandem Beacon Experiment, and they're built by the University of Michigan. This mission explores bubbles in the electrically charged layers of Earth's upper atmosphere. Now, these bubbles can disrupt key communication and GPS signals that we rely on here on the ground. They currently appear and evolve unpredictably and are difficult to characterize from the ground. So the two satellites that will be deployed over the next several minutes are going to help try to understand that problem and find ways to work around it. As you can see on the map, we're currently over East Africa, downlinking through the Mauritius ground station. Again, looking up around 2 o'clock at the top of the stack, trying to see if we can spot the CubeSat coming out of the deployer.
P-pod 6 deploy confirmed.
We've got confirmation over the net. P-pod 6 deployer has opened. We should have the Tandem Beacon Experiment satellite ejected. I was looking for it on the screen, but I didn't spot it. The white objects you've seen coming off to the right-hand side, those are not the CubeSats. Now the second stage is now maneuvering to get in position for the next deployment. That's going to come up in about 5 minutes from now. Half a minute for the 7th of the 8 P-pod openings. This is also a tandem beacon experiment CubeSat. Now, to study those bubbles that I talked about in the Earth's atmosphere, the 2 CubeSats that we're deploying emit signals in a handful of frequencies to stations on the ground. From there, scientists can measure disruptions in the signals to determine how they're affected by the upper atmosphere bubbles. Waiting for call out of P-pod 7 opening and the CubeSat deploying.
P-pod 7 deploy confirmed.
And we've got it, a little late sounding, but we have confirmation. P-pod 7 is open to deploy the second of the 2 beacon experiment satellites for the University of Michigan. And all I've got to say for that is go blue. We're 375 seconds to the final deployment of the P-pod series.
Loss of signal HPK expected.
Well, we're T plus 49 minutes, 15 seconds. We're out between Africa and Australia getting ready for the last deployer, which will release 2 CubeSats that have been working together starting at liftoff. One is the NASA LEO CubeSat, and the second is the STANGSat CubeSat from Merritt Island High School. Now, this combined mission will measure and record the temperature and acceleration data from within that deployer, the P-Pod, during today's launch. Now, in addition to collecting that telemetry data during the launch, STANGSat will stream its data in real time via Wi-Fi to the LEO CubeSat, something that typically we've not seen done before in CubeSats. We're waiting for call out of the CubeSat deploy.
P-Pod 8 deploy confirmed.
Deploy confirmed, and we saw it, at least I did, coming out of the top of the screen. So STANGSat and LEO have successfully separated. And as a reminder, the Merritt Island High School team has been working on this project since 2011, according to their Facebook page. So after waiting a long time for a ride to space, we'll celebrate deployment with Go Mustangs! So we've gotten through the first set of satellite deployments. The Oculus SmallSat and the 8 P-Pods have all opened up. We've got a 21-minute break before we relight the second stage engine to change our orbit. So we'll be back with that. We're going to leave you with the animation that shows where we are in the coast phase, returning at T plus 1 hour, 12 minutes, just about 21 minutes from now, for the second burn of our upper stage engine.
Acquisition West Australia.
Lost signal expected. Diego Garcia.
Loss of signal Mauritius expected. Hobart, or Tasmania acquisition. Loss of signal West Australia expected. Loss of signal Tasmania expected.
Acquisition signal well.
T plus 1 hour 12 minutes since a great liftoff from pad 39A at Kennedy Space Center. We are less than a minute away from the second of our 4 second stage engine burns. In fact, counting down, we're a little more than 25 seconds to go. Currently, we're chilling in the second stage. We're passing over the Southwest Pacific at this time. Everything looking good as we get ready to light the second stage engine. Currently, we're settling propellant down on top of the turbo pumps so that when we spin the pumps, they've got plenty of liquid to pull through and light the engine. Seconds away from ignition.
Engine at power.
We've heard the call out. Engine is at power. This is planned to be about a 22-second burn. Throttling down the MVAC engine. And we heard a report we have good shutdown.
Nominal orbit insertion.
And what we love to hear, the guidance, navigation, and control engineer over the countdown net reports good orbital insertion. So we've had a good burn and a good insertion. Now that we're in the good orbit, we're going to be coasting again for the next 5 minutes or so. We'll be back around T plus 1 hour, 18 minutes, and 30 seconds for our next set of deployments. So stay with us. This will be a series of 10 small satellites, as well as the light sail and 6 cosmic satellites. And ladies and gentlemen, there we've got way out in the Atlantic, even farther away than the drone ship, Ms. Tree successfully with a payload fairing half. The second payload fairing half they've also spotted in the water, but we have accomplished the first landing on the net of a Falcon payload fairing half. So another first time accomplishment for the SpaceX team, especially out there in the middle of the Atlantic Ocean.
Loss of signal.
Welcome back to the STP-2 mission as we await the next set of deployments. First up is PROX-1 microsat developed by students at Georgia Institute of Technology in Atlanta to demonstrate satellite close proximity operations and rendezvous. PROX-1 is not an acronym, but actually got its name from the word proximity. It is basically running some proximity operations or formation flying experiments with the LightSail CubeSat for the Planetary Society. The LightSail will not be released immediately from PROX-1. That will actually happen 7 days after it separates from Falcon Heavy. When this happens, the LightSail will unfurl its mylar sail, which is 1/20th of the thickness of a sheet of paper, with an unfurled area of 344 square feet. This will be the largest solar sail ever demonstrated as a primary means of propulsion. We won't have a visual of this deployment. There is also a good chance we may not have real-time confirmation of deployment since we will be over the Kwajalein ground station. Kwajalein can only record data. It does not send SpaceX real-time. So we may have to wait a few minutes until we come over Guam station to get confirmation of deployment. So again, that deployment should be happening in a couple seconds here. We will get back to you on that confirmation once we get that telemetry back.
Now, the next deployment, and they keep coming, folks, will be for NPSat and will occur in about 2 minutes. NPSat was built by the Naval Postgraduate Research Laboratory, and it carries a bunch of experiments. But in layman's terms, it's investigating the concentration of electrons in the ionosphere, one of the outer layers of Earth which influences radio transmissions. It's also doing experiments to improve communications and the survivability of computers in space, and demonstrating a new type of solar cells for power production. This deployment we will be able to see, hopefully, so let's sit back and wait to see it deploy, and that's coming up in about a minute from now, a little over a minute. Now, looks like we're still waiting to get connectivity, so despite what I just said, we may not get a visual. Hopefully that comes back on for us. Now again, we anticipate hearing a call out of confirmation of deployment for NPSat in about a minute from now. Hopefully we'll get a visual as well. Still waiting on that connection over Guam. We're about 30 seconds away from deployment of the NPSat.
AOS Hawaii.
PROX-1 deploy confirmed.
And we did just hear confirmed over the nets that PROX-1 deploy was confirmed. Very exciting, another successful deployment. And then about 10 seconds from now, hopefully we'll hear the same thing and see it as well for NPSat. And there you see the release on your screen of NPSat, a successful deployment, and confirmed over the nets. Amazing.
The next deployment will be for the General Atomics Electromagnetic Systems Orbital Testbed, or OTB. Separation will occur in just about a couple minutes from now. Due to the positioning of our camera, though, we will not be expecting to see this deployment live. OTB is a versatile modular platform based on a flight-proven hosting model to test and qualify technologies.
SSC Hawaii.
On STP-2, OTB is hosting several payloads for technology demonstration purposes, including the Deep Space Atomic Clock, designed, built, and operated by NASA's Jet Propulsion Laboratory on behalf of the Space Technology Mission Directorate to revolutionize how spacecrafts navigate. This Deep Space Atomic Clock could change the way we navigate in space. It will be the first ever ion clock flown in space and represents the beginning of an era of better space clocks based on the Mercury ion. It loses only 1 second in 9 million years. Any atomic clock for navigation has to be very precise. Even a clock that is off by 1 second could mean the difference between landing on Mars and missing it by miles. In ground tests, the Deep Space Atomic Clock stays stable and keeps correct time for weeks, even months. It's up to 50 times more stable than the atomic clocks on GPS satellites. If the mission can prove the stability in space, it will be one of the most precise clocks in the universe. The toaster oven-sized instrument will be tested in Earth orbit for 1 year, with the goal of being ready for future missions to other worlds. Now we should be seeing this coming up or hearing the call out actually in just about 10 seconds from now. Again, we will not be able to see this live since it is not in our camera view.
OTB payload deploy confirmed.
And we just got that confirmation for the OTB deployment.
Our next deployment is coming up in about 3 minutes, and this is for the Green Propellant Infusion Mission, or GPIM, which is a NASA mission that develops a green alternative to conventional chemical spacecraft propulsion systems. Once NASA demonstrates the fuel and compatible system in space, green propellant could replace hydrazine as the status quo spaceflight propellant. Not only will green propellant be safer, it will also be faster and much less costly. Again, due to the positioning of our camera, we are not expecting to see this deployment live either. But we can listen in for confirmation at about T plus 1 hour and 27 minutes. Hopefully we'll get that confirmation over the nets.
GPIM deploy confirmed.
And we have just confirmed, and we actually saw a little bit of confirmation, of deployment of GPIM satellite. We're now one step closer to changing the way we travel to and around space.
Well, T plus 1 hour, 27 minutes, 40 seconds, and the hits just keep on coming. Next up, in about 4 minutes, is the deployment of 6 Cosmic 2 satellites. Now, Cosmic 2 is a partnership between the U.S. National Oceanic and Atmospheric Administration, the United States Air Force, Caltech's Jet Propulsion Lab in support of NASA, Taiwan's National Space Organization, the United Kingdom's Surrey Satellite Technology Limited, the Brazil Institute of Space Research, and the Australia Bureau of Meteorology. Wow, that's a mouthful, especially an hour and a half into the webcast. Well, this 6 satellite constellation will provide next-generation global navigational satellite system radio occultation data. Now, radio occultation data is collected by measuring the changes in a radio signal as it's refracted in the atmosphere. That means we sample radio signals that have traveled through the atmosphere to measure temperatures and moisture in the Earth's atmosphere layers. This will be used to better predict weather events like hurricanes and model long-term climate trends around the world. Now, if you've seen our simulation of the deployment on the SpaceX webpage, spacex.com, look for STP-2, got a nice video of all the satellite separations. You'll notice that the second stage rotates along the roll axis to orient each of the 6 cosmic satellites for release. So the sequence we go through for each satellite, the second stage slews using cold nitrogen gas thrusters to get to the correct pointing vector, and then we command from the flight computer the signal that will release the satellite. Once that satellite is deployed, the flight computer then commands the stage to rotate to the next position, and another cosmic satellite is deployed, and we'll repeat this process until all 6 are separated. Now, currently we're coming up in a little under 2 minutes for Cosmic 2-5 to deploy. The numbers are 1 through 6, but we don't deploy them in that order. The view you can see from space right now, just a second ago, the SpaceX camera on the back end of the second stage showed the MVAC-D nozzle extension. It's cold after its recent second burn, and we occasionally vent liquid oxygen out the drain tube to help keep pressure stable in the stage. Not this view, but the other one showed one of those nice pieces of solid oxygen. That's oxygen in the vacuum of space. It's so cold that it's turned into solid. It's not a liquid or gaseous oxygen like we breathe. That gives it that very fragile looking Christmas tree look, and it's not very hard. It's a very fragile substance. You'll see those pop off during the flight, and you'll probably see them going past the camera looking forward from time to time as the stage maneuvers around. Now, currently we are in a 3.5 minute maneuver to get to the correct position for the deployments. As I mentioned, the next deployment comes up at just after 31.5 minutes, 1 hour 31.5 minutes into flight. So we're going to wait and look for it. Now, in the view that you can see on your monitor, Cosmic 2-5 is in the top left of center. You can see part of it has a white bottom. That should be the Cosmic 2-5 satellite that we'll see deploy coming up here in just over 1 minute. Just next to it is another one of the cosmic satellites, and then there's a third one also on the right above the one closest to the camera. So we should have 3 good views, and there goes the first cosmic satellite.
2, satellite 5, deploy confirmed.
Right on time, within a second or so of the timeline that was set up days ago, so everything looking good. Now, the cosmic satellites, as I mentioned, are mounted around the dispenser. Now, if you remember again our Iridium missions, we had 2 cylinders mounted on top of each other, each holding 5 satellites. Now, the design for STP-2 has 2 cylinders that hold the cosmic satellites. There are 4 satellites on the lower cylinder, and there are 2 on the upper cylinder. We just saw one of them on the lower cylinder, satellite 5, separate. And of course, just like the Iridium mission, our camera cannot see all sides of the cylinder. So we had a great view just now of the first cosmic deployment, but the next 2 coming up are out of view. Maybe, however, during the next 15 minutes, as we're maneuvering that second stage, we might get a glimpse of the larger satellites as the sun bounces off of them as we head towards evening over the Pacific Ocean. So currently, next separation coming up in just over 2 minutes. That'll be Cosmic 2-6. That one will not be visible from the camera. We'll be back to talk about that in a couple of minutes.
AFSC on Vandenberg acquisition of signal.
Cosmic 2, Satellite 6, payload deploy confirmed.
And we heard confirmation. Avionics Engineering reports, looking at the telemetry, that the Cosmic 2-6 satellite successfully deployed. Now, similar to what we do on Iridium, we've got another 2-minute pause. We'll be back for Cosmic 2-2 deploy. This one also will not be visible from the camera.
Cosmic 2, Satellite 2, deploy confirmed.
And another good call out from Avionics Engineering, watching the telemetry as we're passing through over the Vandenberg ground station now, coming up on the continental US. Cosmic 2-2, the third of the 6 cosmic satellite constellation that performs radio occultation data by sending signals through the Earth's atmosphere, has successfully deployed. Next up will be Cosmic 2-4. That'll be coming up at 1 minute, 1 hour, 39 minutes,
Hawaii
57
expected.
seconds.
Signal FSC and Hawaii expected.
And we are reporting loss of signal as planned of Hawaii, ground station contact with the second stage as we flying further eastward, passing now through the Vandenberg ground stations and coming up on the SpaceX ground station in South Texas a little bit later on. But for now, we've got another couple of minutes.
South Texas.
And there you heard it, the South Texas ground station. SpaceX is located there, has picked up the Falcon Heavy second stage. So we'll be back in a couple of minutes when we listen to the deploy of Cosmic 2-4. This satellite should be visible. It's on the bottom center, or just left of center, that large satellite that was next to 2-5 when it separated a little while ago. We'll be back shortly to watch that deploy. Well, we're about 45 seconds away from the fourth of the 6 Cosmic 2 satellites. This one, hopefully we get a nice view. Currently the camera cycles between views of the nozzle. Now we're looking forward, and then we should stick with the forward looking view, and hopefully we'll see the satellite that's right front dead center there separate, coming up in about 13 seconds. About 10 seconds to go. There it goes.
Cosmic 2, Satellite 4, deploy confirmed.
Cosmic 2, Satellite 4, the one we intended, is on its way into its own orbit. You can see a little bit of that round mounting ring where the satellite was attached to the dispenser that's attached on top of the Falcon Heavy second stage. So next up, we've got Cosmic 2-1. That one is on the back side. That'll be in 3 minutes. We won't be able to see it. And then we'll wrap up with Cosmic 2-3. So we're 4 down, 2 to go of the Cosmic satellites. The P-pods have all opened. They've deployed their CubeSats. The small sats have all deployed. So we've got 2 more Cosmics to go. And then if you can see at the top left of center, that large white flat panel, the very last satellite to be deployed, and that's still another couple hours away almost. That's the DSX satellite that'll cap off the mission. So that one's going to be there for a while, but we'll be bringing you that after we get through the 3rd and the 4th burns of the upper stage engine. But for now, we're going to sit back, watch the video from space, and prepare for Cosmic 2-1 deploy coming up in just over 2 minutes.
Cape J6 acquisition.
2, Satellite 1, deploy confirmed.
Well, we're just over 100 minutes into flight. We've had the 5th successful cosmic satellite deployed, 2-1, out of view, but that means the next one coming up, that's the one right in the middle there. You can see a little bit of the white panel with the circular images on it. That's Cosmic 2-3. We ought to see that one deploy coming up in just about 2.5 minutes. Currently, Falcon Heavy second stage is passing over Mexico, central Mexico. We're contacting through our Texas ground station, and we recently acquired the second stage with the ground station that we have at Kennedy Space Center out on the East Coast. So it's been 104 minutes since we launched, and we're coming up on the end of the first orbit, and it's been a great first orbit. And in addition to all the satellite deployments, as we showed you a little earlier, we caught 1/2 of the payload fairing on the fairing recovery ship Ms. Tree. Just so you know, we only intended to catch 1/2 of the fairing. The other half did go into the water. They did see that. The way we're working it right now is catch 1/2 and make sure that you've got that process understood. Then we'll come back and learn how to do 2 at a time. So right now, coming up, T plus 1 hour 44 minutes and 50 seconds, everything going well. We'll be back for the final deploy of the cosmic satellites shortly.
Cosmic 2, Satellite 3, deploy confirmed.
And we've heard the call out from avionics confirming what we all just got to see. Cosmic 2-3 successfully deployed. That makes 6 for 6 for the cosmic satellites. Everything continuing to go well on the deployment sequence. Now we've had 23 satellites deployed, and we have just one more to go. But to get there, we have a couple of second stage engine burns to perform before we're ready to release that final DSX satellite into space. So for now, we're entering a 20-minute coast phase, so we're going to take a break, but we are leaving you with an animation that shows where we are in the coast phase and some of that great SpaceX music. We'll be back around T plus 2 hours, 7 minutes for the third of 4 ignitions of our second stage engine.